Hello students, welcome to this new session. In this episode, we are going to prove equations of motion through calculus method, right? So, as was earlier discussed, we are considering a body to be in uniformly accelerated motion moving along a straight path. We are dealing with motion in one dimension. Suppose initially at t equals to 0, the initial velocity of the body is u, right? After time t, final velocity of the body is considered to be v. And students, during this time t minus 0, that is t time, during this time t, the displacement of the body, suppose, is considered to be s, and the body possesses a constant acceleration, that is a, which is constant, which is the mandatory condition for a body to possess uniformly accelerated motion. Uniformly accelerated means acceleration of the body must be constant, so that the velocity of the body increases or decreases at a constant rate, right? So, let's try to derive the equations of motion by calculus method. So here, let's begin with the first equation of motion, right? So for that, we are aware the instantaneous velocity of a body is given by limit del t approaches to 0. It simply suggests that the time interval which we are considering is very, very small, infinitesimally or vanishingly small. Del x by del t. Del x is the small displacement in small time del t, right? This term is actually known as the differential coefficient of displacement with respect to time. So student, in calculus, the instantaneous velocity of the body is given by the differential coefficient of displacement with respect to time. It is also known as the derivative of x with respect to time. This is the differential coefficient of displacement x with respect to time t, right? So, this is instantaneous velocity. What we do is, we can write it like this. Also, we can write it as dx by dt. Also, instantaneous acceleration of the body, which is obviously constant. It will be given by limit del t approaches 0, del v by del t. This represents small change in the velocity in very small time del t. Again, I must stress del t represents very, very small interval of time, vanishingly small. So this term is actually known as the differential coefficient of velocity with respect to time. So acceleration is given by this, right? Acceleration is given by this. So using these two expressions for velocity and acceleration, we can easily mathematically derive the equations of motion, right? So as you are aware, first equation of motion is v equals to u plus at. Let's try to prove it. So, to prove first equation of motion, that is v is equal to u plus at. This is to be verified. Now look, it is also known as velocity-time relationship, right? It is also known as velocity-time relationship. So, no displacement involved over here. So, we will consider this particular equation. So, as we are aware, A is equal to dv by dt. Therefore, it can be rearranged in this manner, a dt. Isn't it? Now, taking integration, right? And taking suitable limits. So let's integrate it. So integrating both the sides, integrating both sides and taking suitable limits. What we get is integration of dv is equal to a dt. A being constant, it can be taken outside the integration. And suitable limits means when t equals to 0, initially when t equals 0, what is the initial velocity? U. In the left hand side, we are doing integration with respect to velocity. So the limits of velocity is to be considered. There is the lower limit and there is the upper limit. Here we are doing integration with respect to time. So the limits of time is to be considered. There is the lower limit and there is the upper limit. So at t equals 0, the velocity of the body was u. At t equals to t, the final velocity of the body is v. Now we can easily solve it and we should get the result, right? So it implies that integration dv is v. So a integration dt is t. So upper limit minus lower limit. So what you get is upper limit v minus lower limit u is equal to a upper limit minus lower limit. So what do you get? V is equal to u plus at. This is the first equation of motion, which is also known as the velocity time relationship. So students, remember, in order to derive v equals to u plus at through calculus method, you need to consider this particular expression, the instantaneous acceleration that is given by the differential coefficient of velocity with respect to time, right? Okay. Let's try to mathematically derive the second equation of motion, which is the displacement time relationship. It is s equals to ut plus half at square. So displacement is involved. So we have to make use of this equation, which states that instantaneous velocity is given by the differential coefficient of displacement with respect to time. So let's try to derive the second equation of motion, which is the displacement time relationship, right? So we need to prove this. Second equation of motion is s equals to ut plus half a t square. This is the equation which is to be proved. We know that instantaneous velocity is dx by dt, right? So it can be written in this particular manner. Dx is equal to v dt. Also, it may further be written in this particular manner. Dx is equal to, in place of v, we can write u plus at. From first equation of motion, since v is equal to u plus at. From first equation of motion, right? I simply substitute the value of v as u plus at. Now let's keep on solving it. Opening the bracket, we get u dt plus at dt. Now students, let's integrate it by taking suitable limits. So integrating and taking suitable limits. What we get is integration of dx, it would be equal to u is initial velocity constant, integration dt plus uniformly accelerated motion, so acceleration is constant, t dt. Now remember the limits. Whenever you are integrating with respect to time, then the limits of time are to be substituted, and when it is the case of integration with respect to x, which is displacement, then the limits of displacement is to be considered. So this is the integration with respect to time. Initially, that is at t equals to 0. Displacement of the body is also 0. The body is assumed to be starting from the origin. So at t equals to 0, x equals to 0. At t equals to t, the body has covered displacement s. That is what we have considered. Body has covered displacement s in time t, right? So let's integrate it. Integration dx is x. We are all aware of it. U is constant. Integration dt is t. Integration of t with respect to t is t square by 2. Make use of this formula. Integration of xn with respect to x is xn plus 1 divided by n plus 1. where n is not equal to minus 1. This is the formula to be used, isn't it? And this is the case of definite integral, so no constant is to be introduced. So a, in case of t, we will get t square by 2. T square by 2. Limits can be written like this. Now let's solve it. Upper limit minus lower limit. So what do you get? In place of x, we will write s minus lower limit, that is 0. U upper limit, t minus lower limit, plus half can be taken outside. A, what we get is upper limit t square minus lower limit, that is right. So on solving, we get s minus 0 is s is equal to ut minus 0, we will get ut plus half a multiplied by t square minus 0 square. So we get half a t square. This is the second equation of motion, which is also known as the displacement time relationship. It is also known as displacement time relationship. So this is the derivation of second equation of motion using calculus method, right? So finally, let's also try to mathematically derive the third equation of motion, which is the displacement velocity relationship. That is 2as is equal to v square minus u square. Let's try to prove that as well. Here we are again supposed to make use of instantaneous acceleration, which is given by differential coefficient of velocity with respect to time, as well as instantaneous velocity, which is given by differential coefficient of displacement with respect to time. So we will make use of both these equations. Acceleration, it is given by differential coefficient of velocity with respect to time, and instantaneous velocity, that is given by differential coefficient of displacement with respect to time. We will make use of both these two equations, right? So let's start with this. As a equals to dv by dt. Now multiplying both the sides by dx, because in the third equation, remember, we need to prove this. 2as is equal to v square minus u square. This is to be verified. This is to be mathematically proved. So t needs to be eliminated. Time needs to be eliminated. So what to do is multiplying both sides by dx and rearrange the terms. So what do you get? A dx is equal to v dv. Can you write it like this? I will tell you. Multiplying both the sides by dx. A into dx, dv by dt into dx. Now v is dx by dt. So simply rearrange the terms. What I have done is instantaneous acceleration is given by the time rate change in the velocity, which in calculus is known as the differential coefficient of velocity with respect to time. Multiply both the sides by dx. A into dx is equal to dv by dt into dx. Dx by dt, that will give us velocity. So we can write it like this. Right? Now, integrating both the sides, we get integrating both sides, taking suitable limits. What we get is a can be taken outside the integration since a is constant. Right? Here we are doing integration with respect to velocity. So the limits of velocity have to be considered. What is initial velocity? U at t equals to 0. At t equals 0, the body is at origin. That is, displacement is 0. After t equals to t, what is the final velocity acquired by the body? V. And during time t, the final displacement the body covers during time t is s. Right? Let's solve it. Integration of dx is x. Limits will be from 0 to s. Integration of v to the power 1. So it will be v to the power 1 plus 1 divided by 1 plus 1. So it will be v square by 2. So half v square. Integration of v with respect to v is v square by 2. And limits are from u to v. Therefore, A upper limit minus lower limit, S minus 0. It is equal to half. Again, upper limit minus lower limit, V square minus lower limit. In place of V, substituted by U. So this is it. So what you get is AS is equal to V square minus U square divided by 2. So students, cross multiply it and we will reach the result. That is 2AS is equal to V square minus U square. So this is the third equation of motion, which is also known as displacement velocity relationship. So this is the third method which we have tried to derive the equations of motion. First, through normal mathematical method considering the average velocity. Second, graphically we have derived the three equations of motion. And finally, we have derived the equations of motion using calculus method, using these two concepts. Acceleration given by differential coefficient of velocity with respect to time, velocity given by the differential coefficient of displacement with respect to